Hello everyone, my name is Subham and today in this video I am going to explain you one of the most important questions which is frequently asked in mechanical interviews, and that is what is the difference between reversible adiabatic and isentropic process. But before that we have to see that what is an adiabatic process. So adiabatic process is the process in which the net heat exchange is equal to 0 between system and surroundings. And how can we achieve any adiabatic process? This is also a very frequently asked question in interviews. So these are the three ways in which we can achieve any adiabatic process. Either the process is so fast that there is no time given for any heat exchange, or we can insulate the system like we have insulated the system here, so there is no heat exchange occurring between system and surroundings, or the contact area is so less that there is no possibility of any kind of heat exchange. So these three are the possibilities, and this is the condition for adiabatic processes. So for adiabatic process you can see the final condition, net heat exchange equal to 0. And what is a reversible process? Reversible process is any process in which the useful energy which is present in a system is not destroyed. If we suppose if we take a system from state 1 to state 2, then that system could be brought back from state 2 to state 1 through the same path. So that is what I have shown here, that system is taken from state 1 to state 2, and any kind of reversible process is shown through a continuous curve. So either on PV or TS graph or any other graph, you can get to see any reversible process by a continuous curve. But to represent any irreversible process, we use a discontinuous curve, because all the states in a process are not defined, all the points are not defined, hence we use a discontinuous curve for any irreversible process. So for a reversible process we can call that irreversibility will be equal to 0, and from Gauss-Stodler theorem we can say that the irreversibility present in a system is directly proportional to the entropy which is generated. What is entropy? Entropy is the degree of randomness or which is present in a system, or in other terms we can say that कितना किसी भी सिस्टम में हलचल प्रेजेंट है, कितना हलचल है किसी भी सिस्टम में. सो this entropy generation, actually this entropy generation is directly proportional to the irreversibility which is present in the system. And so for a reversible process you can say that this entropy generation is equal to 0. So collecting this reversible and adiabatic terms, we can get reversible adiabatic conditions will be for adiabatic, net heat exchange between system and surroundings will be equal to 0, and for reversible processes this entropy generation will be equal to 0. Now coming to isentropic term, in an isentropic process the entropy of a system remains constant. Suppose the system is taken from state 1 to state 2. So here you can see this x-axis is entropy, this y-axis is temperature, so it is parallel to y-axis. So here entropy is remaining constant, as you can see from the graph. So this system we can call it to be an isentropic, that it is going through an isentropic process. So in an isentropic process the change in entropy of a system is equal to 0, or the entropy of that system remains constant. And this is the equation for change in entropy of a system. Change in entropy of a system is equal to net entropy transfer between system and surroundings plus entropy generation. So entropy transfer we can say it to be an entropy change. So we can directly we can relate change in entropy is with the net heat exchange. So change in entropy is equal to net heat exchange divided by temperature. So if we integrate this from state 1 to 2, from state 1 to 2, suppose any system is going any process from state 1 to 2, so we can integrate it to this term from state 1 to 2, and then we will get the overall entropy transfer from state 1 to 2. So here it is written, and the entropy generation term is written as Sgen. Now this change in entropy of a system can be zero either in two conditions. First, if it is a reversible adiabatic process. If there will be reversible adiabatic process, then the net heat exchange will be equal to 0. So we can put this dq is equal to 0, and through this reversible process we can call that or we can say that this entropy generation will be equal to 0. So we can, these two terms will become equal to 0, and so this change in entropies of system will become equal to 0. But there is also a special case in which these two terms can become equal in magnitude but opposite in sign. So when this condition will be achieved, then the entropy of the system can become equal to 0, and due to this special case, the entropy, we can say that every isentropic process is not reversible adiabatic due to this special case, but every reversible adiabatic process is an isentropic process. That is what I have written here. Every reversible adiabatic process is an isentropic process, but every isentropic process is not reversible adiabatic. So we can represent it with the help of chart also, that every reversible process you can see here is isentropic, but every isentropic process is not reversible adiabatic. Let's take a system or a point over here. So is this process reversible adiabatic? No. Is this process reversible adiabatic? Yes. Is this point isentropic? Yes. So yeah, but can you take any point in this region which you can call that that point is not isentropic? No, there is no point you can take in this reversible adiabatic region that you can call that it is not an isentropic process. So every reversible adiabatic process is an isentropic process, but every isentropic process is not reversible adiabatic. And this adiabatic process can be of two types, reversible adiabatic or irreversible adiabatic also. So I hope that you have understood the concept with clarity, and if this video has helped you, then please share it with your friends, and if you have liked this video, then please subscribe the channel. Thank you all for watching this video.